one, we already know that x and y are independent, and we know the density function of x and the density function of y. We also know z equals to x plus y. Since x and y are independent, when we have to calculate the density function of z, we can use firstly the convolution method. That is, the density function of z equals to fxz convolved with fyz. And now we already know the density function of x and the density function of y, so we can simply expand it as uz minus 1 minus uz minus 2 convolved with uz minus uz minus 1. And we can expand it like this. That should be uz minus 1 convolved with uz, then minus uz minus 1 convolved with uz minus 1, then minus uz minus 2 convolved with uz, then plus uz minus 2 convolved with uz minus 1. When it comes to the convolution of the step function, we already know that the step function ux convolved with itself should be x times ux. So we already know that in this case, we also have an LTI system, and we can apply the shift property. Then the fzz becomes z minus 1 times uz minus 1 minus z minus 2 times uz minus 2, and minus z minus 2 uz minus 2 plus z minus 3 times uz minus 3. And we can just do some expansions. Then it becomes z minus 1 times uz minus 1 minus 2 times z minus 2 uz minus 2 plus z minus 3 uz minus 3. And that's the question 1, how we can use the convolution method to calculate the density function of z. The second method is to use the geometry method. In this case, we have to firstly draw some pictures. One picture is, since we know z equals to x plus y, we can just define z as y equals to z minus x in this case. Then we already know the density function of x, so we can have the density function of fx, and we already know that x is ranging from 1 to 2. And we also know that fyy equals to uy minus 1. So we can also draw the picture of the density function of y, and we also know that y should be ranging from 0 to 1. In this case, we can simply get the diagram of x and y versus x. So in this case, when z is ranging from 1 to 2, we should have the first picture. In this picture, when we have to calculate the density function of z, we should firstly calculate the distribution function of z, and that should be the area of the shaded part. And we know that the capital Z, fzz equals to z minus 1 to the power of 2 divided by 2. And then we can use the definition of the distribution function fzz equals to d by dz fzz, and that should be z minus 1. And that's the case when z is ranging from 1 to 2. And then the second case, when z is ranging from 2 to 3, we also have the distribution function of z should be the shaded areas. So the area should be fzz equals to z minus 1 to the power of 2 divided by 2 minus 2 times z minus 2 to the power of 2 divided by 2. And we should do some line to help you understand the calculation. That should be this area minus these two areas. So in this case, we have the distribution function of z equals to minus 1 divided by 2 z to the power of 2 plus 3 times z minus 7 divided by 2. So in this case, the distribution function of fzz should be simply equals to minus z plus 3. And in this case, we can do some conclusion. The density function of z equals to z minus 1 when z is ranging from 1 to 2, and minus z plus 3 when z is ranging from 2 to 3. And in other cases, we can simply see from the picture there are no intersections between this area and the line y equals to z minus x. So in this case, in other cases, the density function of z should always be 0. Then, if we draw the picture of this function, that should be the same of this function we have already calculated in the first question. And that is the question, and that is the answer of the first problem. That's all. Thanks.